Hey guys, hope you're, what is it, Thursday now? Sorry, my time gets a little messed up sometimes. I hope your Thursday's going well. Thank you for checking in with me today. Yesterday we kind of talked about supplementary and complementary angles and what makes a supplementary angle. And basically if we have a straight line and there's a line that goes through it, that angle, the two angles that form from that line on each side are supplementary, which means they add up to 180 because a straight line measure is 180. So if there's two angles that make up a straight line, then both of those add up to 180. Well, that's all review from our unit 2, but that was a way long ago, so I wanted to go check back in. When we take things out of just one straight line and we're dealing with two straight lines, and remember, if two lines are going in the same direction out to space, they form a special line. It rhymes with parallel. We call them parallel lines. If they're parallel lines, that means everything's the same about them. So if a line called a transversal line, like this guy right here, goes through two parallel lines, it forms the exact same angles all the way across, which means we have lots of angle pair relationships that we can start diving into. Like for example, the first angle pair relationship I want to talk to you guys about are our basic supplementary pairs. Okay? And that's not an official name. Supplementary pairs show up all over the place on these, but there's basically two sets of them. You got your horizontal pairs. See those horizontal pairs? So these are the lines. These pairs, so if we label these out, 1, 2, 3, 4, 5, 6, 7, 8, like everybody does for those lines. So like my supplementary pairs horizontally would be my angles 1 and 2, 3 and 4, 5 and 6, 7 and 8. So these guys, those guys, these guys, and those guys. Those are your supplementary horizontal angle pairs. You don't have to remember they're horizontal, but they are horizontal, so that's just how I'm like calling them out right now. And these angles together add up to 180. So like if angle 2 was 30 degrees, angle 1 would be 150. Okay? If angle 3 was if angle 3 was like 70 degrees, angle 4 would have to be 110. They're going to add up to 180. That's what that means. And we also have another set of these that show up. It's pretty common sense, but sometimes it's hard to see. And those would just be vertical supplementary pairs. That would be my 1 and 3, my 2 and 4, my 5 and 7, and my 8 and 6. Just vertical supplementary angles that show up. That both these going to add up to 180. So if 6 was 40, 8 would have to be 140. That's all that's saying. Okay, so those would be my supplementary angle pairs. Okay, the next type we like to talk about, we said they were formed from a translation. So if I take like this angle here and I just move it up, notice how it becomes the angle on the other line. Okay, that's called a translation up a transversal line. And angle pair relationships that are formed by translating an angle up onto another angle, those are called corresponding angles. Okay? Corresponding. Okay, and if I draw in my 1 and my 2 and my 3 and my 4 and my 5 and my 6 and my 7 and my 8 like that. I know, I had some coffee this morning, guys. I'm already excited to be teaching. It's just nice to be communicating with the camera and hoping you guys are seeing me on the computer screen. Okay, so with that being said, my corresponding angle pairs would be any pair I can translate up. So if I translate 5, it becomes angle 1. 6 becomes angle 2. Okay, and if I start searching for those, I will see my corresponding angle pairs would be angle 1 and angle 5, angle 2 and angle 6, angle 3 and angle 7, and angle 4 and angle 8. Okay, that means that angle 1 and 5 are going to be equal no matter what. So if you're looking at two parallel lines and we know the measure of angle 1, I can tell you the angle of measure 5 just because of those angle pair relationships. Those are going to be the same. It's kind of cool. It's kind of like playing Sherlock Detective almost on a math level with angles. So we can do that if we know our corresponding angles. Those are our corresponding angle pairs. Okay, there's really no other corresponding angle pairs unless we draw another line, and then we're going to have a lot more that is parallel to it. Okay, so we got our corresponding key things formed by translations. Those angle pairs are always going to be the same. Okay, the same measure. Okay, so let's look at our next set. We call this set vertical angles. Okay, in our vertical angle pairs, we formed those. So we did this by translating. We formed these by reflecting across the transversal lines. So see how this angle flips up, becomes that angle. This angle flips down, becomes that angle. So we reflect it across our transversal line. Okay, so if we draw everything in here and we look at what angles match up after we flip them across something, we're going to get a bunch of angle pairs again. And those angle pairs are going to be the exact same as corresponding, okay? Those, if they're an angle pair by vertical angles, they're going to have the same measure. That's what's cool. Supplementary pairs are the only ones where their measures are going to be different. All corresponding angle pairs are the same. All vertical angle pairs are the same. So if we're looking at ones that are formed, 1 flips down to 4, 3 flips up to 2, 5 flips down to 8, 7 flips down to 6. Those are my vertical angle pairs. So I'm just going to write those down. Angle 1 and angle 4, angle 2 and angle 3, angle 5 and angle 8 and angle 6 and angle 7. Okay? Those are my angle pairs. So if angle 2 was equal to 30 degrees, then angle 3 would be equal to 30 degrees. If angle 8 was 150 degrees, then angle 5 is 150 degrees. Okay? If I really wanted to start applying both of these at the same time, I could do that too. I could say, okay, if angle 8's 150, then I know angle 5 is 150, which means angle 1 is 150, which means angle 4 is 150. Notice how I went, because of vertical angles, 5, because of corresponding angles, 5 and 1 are equal, and because of vertical angles, 1 and 4 are equal. And if I want to bring in my supplementary, I could say, well, if 4 is 150, then I know that 2 has to be 30 because of my supplementary pairs. Okay? It's a fun way to go through these. These are, can you visually reason what's going on by creating these pair relationships to prove stuff. Okay? The last two, okay, these are our kind of different ones. We have our alternate interior and we have our alternate exterior. So when I write in my angles for both of them, these relationships deal with opposite or same side. So if they're on the same side, okay, interior, so these angles here are on the same, are both on the inside of my parallel lines. Okay, so when we're talking about alternate interior, we're just talking about what's happening inside of my parallel lines. Okay, and we have alternate angles. Alternate means opposite sides of my transversal line. So I'm looking for the relationship between the angles inside my parallel lines on opposite sides of my lines. So here, the only alternate interior angles I have that are on opposite sides inside of my parallel lines are angles 3 and 6 and angles 4 and angle 5. Now, that means those angles are equal. Okay, see, 3 and 6 are going to be the same measure. So if 3 is 30, 6 is going to be 30. If 5 is 150, 4 is going to be 150. They're the interior of my parallel lines, opposite sides or alternate sides of my parallel lines. Okay, those aren't too tough. Those are easy to see. Where students get tripped up a lot on this is they forget about the interior piece and they start trying to make comparisons. So they'll say like 5 and 2 because they're on opposite sides, but this guy's exterior and they're not the same measure. The easiest check you can have doing these problems, guys, is just say, hey, does it look the same? If it looks the same, it probably is the same when you're dealing with parallel lines. That's the nice thing about it, okay? Let's look at our alternate exterior. So if I'm breaking down what it means, this is alternate. It's going to mean opposite sides or different sides of my transversal line. So this guy. And exterior means I'm just dealing with things that are on opposite sides or above and below or outside of my parallel lines, okay? So I'm only dealing with 1, 2, 7, and 8. And if I'm looking for the angle that is on the opposite side of the transversal line that's outside of my parallel lines or below, the only one it can be is 8. So that would be angles 1 and angle 8 are always the same. And angle 2 and angle 7 are always the same. Okay? Those are our angle pair relationships. Okay? Do you need to memorize these? It's helpful. Doesn't matter in the long run. I mean, you're always going to be able to grab your phone and Google it. The more important thing that you need to take from this is not these angle pair relationships and what they're called and blah, blah, blah. They might ask you those questions, but if you practice them enough, you don't need to memorize any of this. You can just know what they are. But the key thing is just getting you used to looking at different angles and reasoning that they're the same. If you don't, like, if I'm looking at angle 5 and 1 here, they look pretty similar, okay? So if you can reason, since they look similar, they probably are similar, then I can drop the corresponding take. It's helpful to know, but realistically, in the real world of math, I need to be able to see that angles 5 and 1 work, okay? If you're building a house and you're trying to figure out if your roof pitch is the same and you're looking at 2 sets of 2x4s staring at you, if you see one has an angle that's greater than the other one, they're probably not designed for that same roof. If not, your roof's going to look like a Hobbit roof, which only works in Lord of the Rings. It doesn't work in the real world. There, I said it. Sorry, Tolkien. O'Connor's just rolling in his grave right now. I'm just teasing. O'Connor's fine, guys. Okay, so with that being said, I'm going to just do one example problem. I know this is a longer video than I normally do, but I'm having fun, so I'm just going to keep doing it. Why not? Okay, so I'm going to do the paper rip. Hopefully it doesn't tear down my green screen like it did yesterday when I was setting up for Brogan's Supplementary Angle song. Okay, so that goes away. We're going to draw one set here. Boom, boom. These little carrot looking things tell me that they are parallel lines. So I have 2 parallel lines cut by a transversal. Okay, that's pretty exciting. No? Maybe? Okay, whatever. And I'm just going to label out one angle. Okay, I'm going to close my eyes, and wherever my finger lands the closest to it, I'm going to label that one. Boom. So I'm exterior, outside. That's an obtuse angle, so we're going to call that 125 degrees. So that's the only information that's given to me, and I need to find all my other angles now. So technically I labeled out angle 8, so we're going to go angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, angle 8 equals 125. I want to know what everything else equals, okay? And I'm going to do that with my angle pairs. So the question is, where do I want to start? Okay, let's start with the supplementary. If I know that that's 125, this is horizontal, a horizontal straight line there. So if that's 125, these two add up to 180. So this means that guy is going to have to be, that's correct, class, 45 degrees. Because 45 and 125 is 170. I'm lying, that's 55. It's early in the morning. 55 degrees. Because that'll equal 180. Okay? So now I have these two angles. I could reason everything out with vertical supplementary angles, but I'm not going to. I'm just going to take this and say, you know what? 5 and 8, or 5 and 125 are vertical angles, which means I can reflect 125 onto 5. So I know angle 5 must be 125 degrees. And then I'm going to take angle 7 here, which is 55, and I see that it reflects onto angle 6, which is a vertical angle. So if it reflects, it's a vertical angle. They're the same. So angle 6 has to be 55 degrees. Okay? If I want to check my work on that, 55 plus 125 is 180. That's still supplementary, so I know that's correct. Okay? Now from here, I'm going to take my angle 5, which was 125, and I'm going to just translate it up till it becomes angle 1. If I translate it up, that's a corresponding angle. Okay, so, and that means it's the same. So if angle 5 is 125, then angle 1 has to be 125. Okay? If angle 6 is 55, when I translate it up, it is also has to be 55 for angle 2. Now I could supplementary vertical angle from there, it doesn't really matter, but let's just pretend, let's just use our other ones real quick. Let's say that angle 3 and angle 6 are both inside of my parallel lines, but on opposite sides or alternate sides. That means they're the same. So if 6 is 55, 3 is 55. And then I can take my logic with 3 being 55 and flip it over with a reflection and to get 2 is 55, so that's the same, which means this has to be 125. Vertical angles or alternate interior angles. That's how you reason through those things. Today, we're not going to get into the algebra of it. We're not going to dive deep like that. I just want you guys to focus hard on getting really good at identifying which angles are the same, which angles are different. Okay, if you want to do a smell test to see if you want to taste something, okay, like if it's like that raccoon commercial on Geico. You know, I'm not like, oh, this is the worst thing I've ever tasted, come try it. No, you're not going to try it. It doesn't make sense. If something tastes bad, you're not going to put it in your mouth. Okay, same thing here. If the angles don't look the same, they're probably not. Okay, so if you're looking and you're saying, you know, I think 1 and 6 are the same because they're on opposite sides. Okay, well 1's obviously not the same as 6. 6 is a smaller measure, so don't make that mistake. Okay, it's a common mistake, especially when you're going through things quickly and not paying attention. But this is the kind of stuff where if you just look at the details, make sure it matches your answer. You guys got this. We have a quick matching game. We have a quick quizzes. And then I want you guys to just work on that tangled web. That tangled web game on Mega High is a great game for getting used to these angle pair relationships and these measurements and how everything fits together. And it kind of takes you to the next level because it starts talking about the full circle, which would look like that, which is 360 degrees, and it helps you guys reason through that. So just do your best today, guys. It's Thursday. Tomorrow I got a quick quiz for you guys. It should be fun. Other than that, next week we don't have these every day, so if you can just power through these next 2 days, next week's your spring break technically. I got lots of stuff I'm working on with ASB. It's Throwback Thursday. I would love to see you guys decked out in your throwback gear. You can find that on the Spirit Week information that was emailed out to you earlier this week. So please participate. It'll be a lot of fun. I think we're going to try to get some better Spirit Week ways for us to connect after the break. Have a great one. Good luck with your work today. Have a good day.